So for our project, Steve and I chose to do arc flash mitigation, and a way to use Arduino to mitigate arc flashes. So here's an arc flash explosion in the field. This guy's just working, and little does he know that he's about to not go home. So what our project goal was, we wanted to design a cheap but effective method for mitigating arc flash explosions, and we wanted to model it on a small scale. So our plan would be to model like a small motor control center that's being fed by the grid or the switch yard, and we'd use an Arduino to sense the voltage potential across an open breaker that someone may be working on a motor, or they may have a breaker open in a motor control center. They may even just be working around a motor that's being worked on. So for this, we'll use two relays as our main breaker. So we'll have one relay we'll call the main relay, and that'll control power to, that'll be like the feeder breaker to the motor control center, and the other relay will be the sensing relay, which will sense the potential on the motor control center. And to actuate the relay, we'll use an NPN transistor. So the first question is, how does an arc flash occur? Well, an arc flash occurs in two main different ways. So the way that this program, or our programming, will mitigate an arc flash is if there's a power spike. Another way that an arc flash can occur is if a grounding occurred while someone was working inside a breaker. But basically, this is the formula that you would use to determine the voltage that you would need over a certain distance between an open breaker. So the first thing that has to be done when dealing with arc flash mitigation is an arc flash study. So what they do is they'll go into the power plant, and they'll first apply that equation to figure out what's the potential for an arc flash to occur. Then they'll go through and they'll set up like different boundaries and PPE requirements. So here we have an example of a sticker that they would put on something, and it tells you what the arc flash boundary is, what PPE is needed. So this is, you need level 1 PPE and whatever certifications you need to be in this area. So Steve was away on a golf trip, but he put together a video to explain the basics of our project.
Normal plant, everything's in normal operation. You have power coming in through your main relay, into your motor controller, and going to the motors, and everything's spinning perfectly. All of a sudden you have a major spike. Your sensing relay is going to sense that across your motor controller, which then causes current to flow all the way back to pin number 2. Pin number 2 sees a signal, which then cuts off power to pin 13, which then opens up the transistor, NPN transistor, which then stops flow of this circuit, the positive 13 through the transistor out, and cuts power to your motor control. Alright, now you know how all the different parts of the system are working together to save your life, basically. Let's put it to use. Power on. Come on, bud. What are you doing? Don't embarrass me. Alright. So right now we have it about 6 volts or something coming in. You could, if you need a demand higher than this, it goes up. Perfect. But say you know that you need to do maintenance on one of these motors, then you're going to have, obviously, the switch off, preventing power going to that. When you do that, you have to have your safety switch on. This completes the circuit for this sensing relay. Say you're working on it, you're going to have an arc across this on accident, not on purpose. You never want to have that happen. That will make this motor run. This little buddy right here and these guys are going to prevent that. So we're going to have a voltage spike right now. Boom. Cuts the power off. And that's basically how everything's working together. So the reset part, you're going to have to make sure that your power is back down to a nice steady level where normal operation is. So then you have to reset your coil on this guy, on the safety switch. Put the power back on. So just in case power still is high, this will trip again. Now you have to reset your Arduino. Now you see currents flowing through. All good.
So further recapping what Steve just said, we have 7 volts coming into our feeder breaker. From here, when this is made, it will go into our motors and run our motors. So when we engage the safety switch, we then see that it is now sensing this voltage coming in. So when the safety switch is on and this is sensing that voltage, if it spikes, this relay will make. When this relay makes, it'll output, or it'll complete the circuit outputting a signal to pin number 2. When pin number 2 sees any value, it will tell pin 13 to stop outputting 5 volts to the NPN transistor. When the NPN transistor, once this stops receiving the 5 volts, this will act closed and will tell this thing to de-energize, opening up this switch, depowering all of our motors. So that's basically it for our ArcFlash project. It turned out to be a success. So something further that we were thinking could be done with this is we would like to program the Arduino to trend this information so we can see if there's spikes or not. And if an arc flash were to occur, you would want to be able to see all the data leading up to it. So we hope you guys enjoyed our project, and thanks for listening.